the sky so very high, just like a dragonfly. I fly above the trees, over the seas, and on the breeze, anywhere I please. Oh, I want to get away, I want to fly away. Yeah, yeah, yeah. I want to get away, I want to fly away. Yeah, yeah, yeah. Let's go and see the stars, Milky Way, River Mars, we could just be ours. Let's fade into the sun, let our spirit fly, 'cause we are one, just for a little fun. Oh, oh, oh yeah. I want to get away, I want to fly away. Yeah, yeah, yeah. I want to get away, I want to fly away. Yeah, yeah, yeah.
Mathematicians sometimes pose seemingly pointless questions. A question like this, for instance: there are 10 different books on a shelf. If it took an individual an average of 3 minutes to rearrange these books, How long would it take them to create every possible arrangement? There is a point to this question. The answer reveals something about the complexity of a simple process. Here's how you solve this. Let's start by posing this same question but with fewer books. Here we have 3 books. The first thing we need to determine is how many possible different arrangements there are. It should be a simple task to actually complete all possible arrangements and count them. We assume the books sit on the shelf in a normal vertical position. This is a first possible arrangement. This is a second arrangement, third, fourth, fifth, and sixth. 6 possible ways to arrange the books. If you inspect the arrangements, you will see there are no other ways to arrange these books. To analyze this process, we will use some math. Here's how a mathematician would approach this. We have 3 books to put on a shelf. We have 3 choices for the first book, and once we have made that choice, we have 2 choices left for the next book. Once we've made that choice, we have only 1 choice left for the last book. The mathematician multiplies these 3 options together. 3 times 2 times 1 gives us 6 possible arrangements. This number agrees with our original investigation. Mathematicians have a special notation for this technique. 3 times 2 times 1 is called 3 factorial. The notation looks like this. The exclamation mark tells us we are multiplying 3 times 2 times 1. The integers decrease by 1. This technique is powerful. Let's suppose we needed to calculate how many ways we could organize 4 different books on a shelf. The answer is 4 factorial. 4 times 3 times 2 times 1. A total of 24 possible arrangements. No need to actually create each arrangement. Let's go back to our 3 books. We know there are 6 possible arrangements. How long would it take someone to complete all 6 of these arrangements? If it takes them 1 minute to make and check each arrangement, 6 times 1 minute is 6 minutes. It probably wouldn't take that long, but using 1 minute keeps the arithmetic simple. Now let's apply this to a slightly larger book arrangement, 10 books. How long would it take someone to arrange these 10 different books in every possible way? We have more books, so let's allow 3 minutes to complete each arrangement. How long do you think it would take them to complete this task? The answer is surprising. Let's calculate. We have 10 different books, so 10 factorial will give us the number of possible arrangements. 10 times 9 times 8 and so on. Multiplying, we get an astounding 3,628,800 possible arrangements. How long would it take to set all of these up? We've allowed 3 minutes for each arrangement. 3 minutes times 3,628,800 gives us 10,886,400 minutes. To change the time to hours, let's divide this by 60. Completing that division, we get 181,440 hours. If the person doing these arrangements decided to spend 30 hours a week at this task, how many weeks would it take them to complete it? Dividing 181,440 hours by 30, the number of work hours per week, we get 6,048 weeks. Now let's change this to years. There are 52 weeks in a year. Dividing 6,048 weeks by 52, we find this task would take an incredible 116 years to complete, more than a century. Who would have thought that it could take over 100 years to complete such a simple task? Obviously, calculating how many ways to arrange a bookshelf is not particularly important, but mathematical techniques like this play important roles in sophisticated tasks. Tasks like analyzing the base pair configurations of DNA. The powerful tools and techniques of mathematics continue to reveal more about the processes that drive all aspects of our universe. For more science-related videos and projects, visit our website, hylaroad.com.